The term stained glass can refer to colored glass as a material or to works created from it. Throughout its 1,000-year history, the term has been applied almost exclusively to the windows of churches, mosques and other significant buildings, although traditionally made in flat panels and used as windows. The creations of modern stained glass artists also include three-dimensional structures and sculpture. Modern vernacular usage has often extended the term stained glass to include domestic lead light and objets d'art created from cane glasswork, exemplified in the famous lamps of Louis Comfort Tiffany. As a material, stained glass is glass that has been colored by adding metallic salts during its manufacture. The colored glass is crafted into stained glass windows in which small pieces of glass are arranged to form patterns or pictures, held together by strips of lead and supported by a rigid frame. Painted details and yellow stain are often used to enhance the design. The term stained glass is also applied to windows in which the colors have been painted onto the glass and then fused to the glass in a kiln. Stained glass, as an art and a craft, requires the artistic skill to conceive an appropriate and workable design, and the engineering skills to assemble the piece. A window must fit snugly into the space for which it is made, must resist wind and rain, and also, especially in the larger windows, must support its own weight. Many large windows have withstood the test of time and remained substantially intact since the late Middle Ages. In Western Europe, they constitute the major form of pictorial art to have survived. In this context, the purpose of a stained glass window is not to allow those within a building to see the world outside or even primarily to admit light, but rather to control it. For this reason, stained glass windows have been described as illuminated wall decorations. The design of a window may be abstract or figurative, may incorporate narratives drawn from the Bible, history, or literature, may represent saints or patrons, or use symbolic motifs, in particular armorial. Windows within a building may be thematic, for example, within a church, episodes from the life of Christ; within a parliament building, shields of the constituencies; within a college hall, figures representing the arts and sciences; or within a home, flora, fauna, or landscape. Manufacture. Glass production. During the late medieval period, glass factories were set up where there was a ready supply of silica, the essential material for glass manufacture. Silica requires very high heat to become molten, something not all glass factories were able to achieve. Such materials as potash, soda, and lead can be added to lower the melting temperature. Other substances, such as lime, are added to rebuild the weakened network and make the glass more stable. Glass is colored by adding metallic oxide powders or finely divided metals while it is in a molten state. Copper oxides produce green or bluish-green, cobalt makes deep blue, and gold produces wine red and violet glass. Much modern red glass is produced using copper, which is less expensive than gold and gives a brighter, more vermilion shade of red. Glass colored while in the clay pot in the furnace is known as pot metal glass, as opposed to flashed glass. Cylinder glass or muff. Using a blowpipe, a gather of molten glass is taken from the pot heating in the furnace. The gather is formed to the correct shape and a bubble of air blown into it. Using metal tools, molds of wood that have been soaking in water and gravity, the gather is manipulated to form a long, cylindrical shape. As it cools, it is reheated so the manipulation can continue. During the process, the bottom of the cylinder is removed. Once brought to the desired size, it is left to cool. One side of the cylinder is opened. It is put into another oven to quickly heat and flatten it, and then placed in an annealer to cool at a controlled rate, making the material more stable. Hand-blown, cylinder and crown glass were the types used in ancient stained glass windows. Crown glass. This hand-blown glass is created by blowing a bubble of air into a gather of molten glass and then spinning it, either by hand or on a table that revolves rapidly like a potter's wheel. The centrifugal force causes the molten bubble to open up and flatten. It can then be cut into small sheets. Glass formed this way can be both colored and used for stained glass windows, or uncolored as seen in small paned windows in 16th and 17th century houses. Concentric, curving waves are characteristic of the process. The center of each piece of glass, known as the bullseye, receives less force during spinning, so it remains thicker than the rest of the sheet. It also has the distinctive lump of glass left by the pontil rod, which holds the glass as it is spun out. This lumpy, refractive quality means the bullseyes are less transparent, but they have still been used for windows, both domestic and ecclesiastical. Crown glass is still made today, but not on a large scale. Rolled glass is produced by pouring molten glass onto a metal or graphite table and immediately rolling it into a sheet using a large metal cylinder, similar to rolling out a pie crust. The rolling can be done by hand or machine. Glass can be double-rolled, which means it is passed through two cylinders at once to yield glass of a specified thickness. Glass made this way is never fully transparent, but doesn't necessarily have much texture. It can be pushed and tugged while molten for certain effects. For distinct textures, the metal cylinder can be imprinted with a pattern that is pressed into the molten glass as it passes through the rollers. The glass is then annealed. Rolled glass was first commercially produced around the mid-1830s and is widely used today. It is often called cathedral glass, but this has nothing to do with medieval cathedrals, where the glass used was hand-blown. Flashed glass. Architectural glass must be at least 1/8 of an inch thick to survive the push and pull of typical wind loads. However, in the creation of red glass, the coloring ingredients must be of a certain concentration, or the color will not develop. This results in a color so intense that at the thickness of 1/8 inch, the red glass transmits little light and appears black. The method employed is to laminate a thin layer of red glass to a thicker body of glass that is clear or lightly tinted, forming flashed glass. A lightly colored molten gather is dipped into a pot of molten red glass. That is then blown into a sheet of laminated glass using either the cylinder or the crown technique described above. Once this solution was found for making red glass, other colors were also made this way as well. A great advantage is that the double-layered glass can be engraved or abraded to reveal the clear or tinted glass below. A number of artists have embraced the possibilities flashed glass gives them. For instance, 16th-century heraldic windows relied heavily on a variety of flashed colors for their intricate crests and creatures. In the medieval period, the glass was abraded. Later, hydrofluoric acid was used to remove the flash in a chemical reaction, and in the 19th century sandblasting started to be used for this purpose. Modern production of traditional glass. There are a number of glass factories, notably in Germany, USA, England, France, Poland and Russia, which produce high-quality glass, both hand-blown and rolled. Modern stained glass artists have a number of resources to use and the work of centuries of other artists from which to learn as they continue the tradition in new ways. In the late 19th and 20th centuries there have been many innovations in techniques and in the types of glass used. Many new types of glass have been developed for use in stained glass windows, in particular Tiffany glass and dalle de verre. Colors. Transparent glass. Ordinary soda lime glass appears colorless to the naked eye when it is thin, although iron oxide impurities produce a green tint which becomes evident in thick pieces or can be seen with the aid of scientific instruments. A number of additives are used to reduce the green tint, particularly if the glass is to be used for plain window glass, rather than stained glass windows. Additives that reduce the green tint include manganese dioxide, which produces sodium permanganate, and may result in a slightly mauve tint, characteristic of the glass in older houses in New England, US. Selenium has been used for the same purpose. Green glass. While very pale green is the typical color of transparent glass, deeper greens can be achieved by the addition of iron oxide, which results in a bluish-green glass. Together with chromium, it gives glass of a richer green color, typical of the glass used to make wine bottles. The addition of chromium yields dark green glass, suitable for flashed glass. Together with tin oxide and arsenic, it yields emerald green glass. Blue glass. In medieval times, blue glass was made by adding cobalt, which at a concentration of 0.025 to 0.1% in soda-lime glass achieves the brilliant blue characteristic of Chartres Cathedral. The addition of sulfur to boron-rich borosilicate glasses imparts a blue color. The addition of copper oxide at 2 to 3% produces a turquoise color. The addition of nickel, at different concentrations, produces blue, violet, or black glass. Red glass. Metallic gold, in very small concentrations, produces a rich ruby-colored glass. In lower concentrations it produces a less intense red, often marketed as cranberry glass. The color is caused by the size and dispersion of gold particles. Ruby gold glass is usually made of lead glass with tin added. Pure metallic copper produces a very dark red, opaque glass. Glass created in this manner is generally flashed. It was used extensively in the late 19th and early 20th centuries and exploited for the decorative effects that could be achieved by sanding in engraving. Selenium is an important agent to make pink and red glass. When used together with cadmium sulfide, it yields a brilliant red color known as selenium ruby. Yellow glass. Silver compounds are used as stain applied to the surface of glass and fired on. They can produce a range of colors from orange, red to yellow. The way the glass is heated and cooled can significantly affect the colors produced by these compounds. The chemistry involved is complex and not well understood. The addition of sulfur, together with carbon and iron salts, is used to form iron polysulfides and produce amber glass ranging from yellowish to almost black. With calcium it yields a deep yellow color. Adding titanium produces yellowish-brown glass. Titanium is rarely used on its own and is more often employed to intensify and brighten other additives. Cadmium together with sulfur results in deep yellow color, often used in glazes. However, cadmium is toxic. Uranium can be added to give glass a fluorescent yellow or green color. Uranium glass is typically not radioactive enough to be dangerous, but if ground into a powder, such as by polishing with sandpaper, and inhaled, it can be carcinogenic. When used with lead glass with a very high proportion of lead, it produces a deep red color. Purple glass. The addition of manganese gives an amethyst color. Manganese is one of the oldest glass additives, and purple manganese glass has been used since early Egyptian history. Nickel, depending on the concentration, produces blue, or violet, or even black glass. Lead crystal with added nickel acquires a purplish color. White glass. Tin oxide with antimony and arsenic oxides produce an opaque white glass, first used in Venice to produce an imitation porcelain. White glass was used extensively by Louis Comfort Tiffany to create a range of opalescent, mottled and streaky glasses. 13th century window from Chartres showing extensive use of the ubiquitous cobalt blue with green and purple-brown glass. Details of amber and borders of flashed red glass. A 19th century window illustrates the range of colors common in both medieval and Gothic Revival glass. Lucien Bigula, Leon. A 16th century window by Arnold of Nijmegen showing the combination of painted glass and intense color common in Renaissance windows. A late 20th century window showing a graded range of colors. Ronald Whiting, Chapel Studios, Tattershall Castle, UK. A window by Tiffany illustrating the development and use of multicolored flashed, opalized and streaky glasses at the end of the 19th century. Creating stained glass windows. Design. The first stage in the production of a window is to make, or acquire from the architect or owners of the building, an accurate template of the window opening that the glass is to fit. The subject matter of the window is determined to suit the location, a particular theme, or the whim of the patron. A small design called a vidimus is prepared which can be shown to the patron. A scaled model maquette may also be provided. The designer must take into account the design, the structure of the window, the nature and size of the glass available, and his or her own preferred technique. A traditional narrative window has panels which relate a story. A figurative window could have rows of saints or dignitaries. Scriptural texts or mottos are sometimes included, and perhaps the names of the patrons or the person as whose memorial the window is dedicated. In a window of a traditional type, it is usually left to the discretion of the designer to fill the surrounding areas with borders, floral motifs and canopies. A full-sized cartoon is drawn for every light of the window. A small church window might typically have 2 lights, with some simple tracery lights above. A large window might have 4 or 5 lights. The east or west window of a large cathedral might have 7 lights in 3 tiers with elaborate tracery. In medieval times, the cartoon was drawn directly on the surface of a whitewashed table, which was then used as a pattern for cutting, painting and assembling the window. The cartoon is then divided into a patchwork, providing a template for each small glass piece. The exact position of the lead which holds the glass in place is also noted, as it is part of the calculated visual effect. Selecting and painting the glass. Each piece of glass is selected for the desired color and cut to match a section of the template. An exact fit is ensured by grazing the edges with a tool, which can nibble off small pieces. Details of faces, hair and hands can be painted onto the inner surface of the glass using a special glass paint which contains finely ground lead or copper filings. Ground glass, gum arabic and a medium such as wine, vinegar or urine. The art of painting details became increasingly elaborate and reached its height in the early 20th century. From 1300 onwards, artists started using silver stain, which was made with silver nitrate. It gave a yellow effect ranging from pale lemon to deep orange. It was usually painted onto the outside of a piece of glass, then fired to make it permanent. This yellow was particularly useful for enhancing borders, canopies and halos, and turning blue glass into green glass. By about 1450, a stain known as cousin's rose was used to enhance flesh tones. In the 16th century, a range of glass stains were introduced, most of them colored by ground glass particles. They were a form of enamel. Painting on glass with these stains was initially used for small heraldic designs and other details. By the 17th century, a style of stained glass had evolved that was no longer dependent upon the skillful cutting of colored glass into sections. Scenes were painted onto glass panels of square format, like tiles. The colors were then annealed to the glass before the pieces were assembled. A method used for embellishment and gilding is the decoration of one side of each of 2 pieces of thin glass, which are then placed back to back within the lead came. This allows for the use of techniques such as angel gilding and églimise to produce an effect visible from both sides but not exposing the decorated surface to the atmosphere or mechanical damage. Assembly and mounting. Once the glass is cut and painted, the pieces are assembled by slotting them into H-sectioned lead camas. All the joints are then soldered together and the glass pieces are prevented from rattling and the window made weatherproof by forcing a soft oily cement or mastic between the glass and the camas. In modern windows, copper foil is now sometimes used instead of lead. For further technical details, see cane glasswork. Traditionally, when the windows were inserted into the window spaces, iron rods were put across it at various points to support its weight. The window was tied to these rods with copper wire. Some very large early Gothic windows are divided into sections by heavy metal frames called ferramenta. This method of support was also favored for large, usually painted, windows of the Baroque period. Technical details. Maquette by Heaton, Butler and Bain, 19th century English manufacturers. Exterior of the window at SE Acute Vela de Coimbra, Portugal, showing a modern steel armature, a set of glazier's tools, skilled glass cutting and leading in a 19th-century window at Meaux Cathedral, France. Colors and mediums for painting on glass. A palette and tools to prepare colors for painting on glass. A small panel by G. Owen Bonawit at Yale University. 1930, demonstrates grisaille glass painting enlivened with silver stain. Swiss armorial glass of the arms of Unterwalden, 1564, with typical painted details, extensive silver stain, cousin's rose on the face, and flash, ruby glass with a braided white motif. Detail from a 19th or 20th century window in Eneberg, Belgium, showing detailed polychrome painting of face.